You see it has T1, T1, and then A. Is there a relationship between the A and the T1? One of these equations? You see here this equation? That equation gives us a relationship between the A and the T1. We know 4T1 plus 3A is 18. What if we take the A, we substitute it into here? And then these two are already T1. It can give us just one variable, right? So that's what I'm going to do. It's better to do that versus take the T1, substitute it for T1, put it into this T1, put it into this T1, and then solve for A. There's too much work because you have to put it into here, and then you have to square it. It'll be just a lot harder. So it's better just to say 18 minus 4T1 over 3, right? This minus this over 3, that's equal to A. Take that, substitute it into there, okay? 2T1 squared plus 12T1 plus 9 over 2. A is equal to 18 minus 4T1 over 3. Okay, how does that simplify? Well, 2 goes into here, becomes what? 9. 2 goes into here, becomes what? 2. 3 goes into here, becomes 3. So we basically have 2T1 squared plus 12T1 plus, the 2 canceled out, so the 2 disappears. 3 goes into here, 9, so we have a 3 left over. And then 2 went into there 9 times. 2 went into here twice. Okay? So we have exactly achieved what we want. We have just one equation with one variable. We can simplify it, solve for the quadratic equation, and we got it. Okay, so 2T1 squared plus 12T1 plus 3 times 9, 27, minus 3 times 2, 6T1 equals 80. Okay, let's erase some of these. And we have here 2T1 squared, 12T1 minus 6T1. That's going to be 6T1. And then 27 minus 80, T3. Okay? So now let's put this into the TI and we can just solve it as a quadratic equation. Solve 2x squared plus 6x minus 53 equals 0. Okay, T1 is going to be 3.862 seconds. Okay, you remember the product of T1 and T2 had to equal what? 30, right? So now from there, if we know T1 is equal to 3.86, we could put it here, we could solve for T2. T2 is equal to 30 divided by 3.862. .7768 seconds. Okay, and then from there you can actually calculate quite a bit of stuff, right? The acceleration was equal to what? Acceleration was equal to 18 minus 4t over 3. So 18 minus 4 times this guy, 3.862 over 3. 851 meters per second squared. Okay, so the acceleration during that last portion of the race for 3 seconds was 0.851 meters per second squared. What's the total time of the race? T total is going to be 3.862 plus 7.768 plus, this is the first stage. Second stage, what is the third stage? 3 seconds, right? So you add that, 14.862 plus 7.768 plus 3, 14.63 seconds. Okay? So the total time of the race, 14.63 seconds. The final acceleration, 0.851. Let's do a quick check. Let's see if we work backwards, whether or not our answers will work out. So this is a quick check. If the runner starts out with initial velocity 0, accelerates for 4 meters per second squared, accelerates at 4 meters per second squared for a time of 3.862 seconds, what is his final velocity going to be at the end of that? The acceleration times the time, right? So we can now, we're working backwards to check the answer. 4 times 3.862. 15.448 meters per second, right? So now the second time interval is 7.7. Time is 7.768, right? So if you go constant velocity of 15.448 at a time of 7.768, what's the distance that you're going to cover? The distance you're going to cover, just the product of the two, right? Velocity times time. So 15.448 times 7.768, 120 meters, right? 120.000064. So there's some rounding error, but more or less 120 meters. So far, it looks like our answer is working out because we got the same answer that we knew of, that we knew that it already had 120 meters, right? So then, from that point on, you accelerate. We don't know what, but the answer was 0.851 for a time of 3 seconds. What's going to be the final velocity, right? So the final velocity is going to be the initial velocity plus AT. The initial velocity is 15.448 plus 0.851 times 3. The final velocity is 15.448 plus 0.851 times 3. It was 18.001, so pretty much 18. So remember the final velocity was 18 meters per second. So that one is working out. The distance 120 is working out. The final thing to check is the total distance has to be 200 meters, right? So what's going to be the distance traveled in the first stage? So you're going to have half times 4 times this time squared. So that's going to be 2 times 3.862 squared. 29.830 meters. Okay? What's going to be the distance traveled in the third stage? D3, the initial t plus half at squared. What was the initial? 15.448. What was t? 3 seconds. What was a? 0.851. So compute that. 15.448 times 3 plus 0.5 times 0.851 times 9. 50.174 meters. Okay, again, there's some rounding error there. So if you add this to 120, what should you get? Total distance. 29.83 plus 120 plus 50.17. Okay, I think I should cut this off, the 4 here, so that it will actually work out. Because this 4 is probably there because of rounding errors. So when you add them, you're going to get 29.83 plus 120 plus 50.17. The sum of all three, 200 meters. Then you put a happy face. The whole problem works out, right? So now we know the 120 works out, the 200 works out, the final velocity works out, and then everything works out. So that's the way to check this answer. So it's a good example of a kinematics problem where there are quite a lot of unknowns, but with a good picture and with an analysis of the problem, you can solve these kinds of problems, okay? Thank you very much.